However, I have visited the NIH over 10 times to make the point that they should put things to this research. I was on a panel or task force for the National Science Foundation, and the idea of doing any research was utterly rejected on their research on their methods of doing peer review. So I'm thrilled that you are all here, that this has become now suddenly fashionable, and in particular that Richard Nakamura agreed to come here. I was standing on his chest at the time, but he agreed. So, good luck.
Okay, well, I think we ought to clap. Thanks. Thanks very much, Drummond. Actually, I was involved in an expert panel on peer review earlier this year for the Canadian Institutes of Health Research, and they are doing a huge amount of research there. They have tons of data. I encourage them very strongly to submit to the next peer review congress, so let's hope they will. Anyway, without further ado, we'll carry on with the afternoon. Great, there's so many of you here. It's really wonderful to have such a great turnout at this stage in a conference. I think it says a lot. Without further ado, we have Joao, yes, we've been discussing pronunciation, Martins, and he's going to talk to us about geographic and gender bias in peer review of applications submitted to the Swiss National Science Foundation. Oh, I forgot to say I'm Trish Groves from the BMJ. Sorry. Over to you, thank you.
Hi. Before getting started, I just want to thank the organizers of this Congress. Also thank my colleagues, François Delavie, who should be here anytime soon, and Anne Jorstad for helping me with this project. And thank, of course, Professor Matthias Egger for pushing us to share some interesting internal data on peer review with you here today. So, let's start. My name is Joao Martins, as you heard, and I'm a data analyst at the Swiss National Science Foundation in Bern, Switzerland. The Swiss National Science Foundation, also known as SNSF, or FNS, or SNF, is the main public funder, the main public funder in Switzerland, supporting not only physical sciences and engineering, like the NSF, but also biomedical research, like the NIH, as well as social sciences and humanities, like no other. In terms of annual budget, in billions here, the SNSF is substantially smaller than the NIH or the NSF. However, of course, if we take into account the fact that the population of the US is 40 times larger than the Swiss, we get comparable per capita budgets. In terms of number of grants, currently the SNSF awards almost 900 new grants per year to bottom-up research projects to establish researchers. If you're not done with counting here, don't worry. If we account now for rejected grants, then we talk about nearly 1,900 grant applications per year. In other words, at the SNSF, success rates are about 50%. Welcome to Switzerland. But prior to decision on approval or rejection, the 1,900 grant applications result in about 6,000 external grant reviews, which means that each grant application gets, on average, 3 external independent reviews. So the first step of the evaluation of a grant application consists of asking external experts to give a general score or to the overall quality of a grant application, somewhere between poor, 1 here, and outstanding, 6. And as you can see here, over a period of 7 years, from 2009 to 2015, most of grant applications got high or excellent scores. Yet, we need to understand whether these scores actually are linked to quality or whether are there any confounding effects such as factors such as gender or source or geographic location of the reviewers or gender of the applicants. So let's start with the origin of the reviewers. If we look at the geographic origin of the experts, meaning whether the experts are based in Switzerland or abroad, we see that Swiss-based experts tend to be much harsher towards their Swiss colleagues applying for funding at the SNSF. Now, one thing you need to know is that typically 1 out of 3 reviews is done by applicant-proposed experts. And for these applicant-proposed experts, there's a surplus of reviews getting outstanding scores. No surprise, I suppose. Then we come to gender. If we look at the review scores of male and female applicants separately, then it seems that men get relatively more outstanding review scores than women, though the difference here is not so large as before. Interestingly, if we look at the gender of the reviewer, men also seem to be more generous than women when reviewing to the SNSF. But now we need to rule out any possible confounding factors that could also be explaining these differences. So we looked at other things as well. We looked, for instance, as we can see here, one on the left, that there was a significant drop in the mean scores if we plot these scores against the year of submission, which is probably due to harsher review guidelines or guidelines to reviewers. On your right hand, then we see that the age of the applicants is also a factor to take into account because older applicants are performing better than younger ones. Then there's also factors such as academic discipline or the type of affiliation. As you can see on the left, mathematicians seem to be more generous than economists. There are differences between disciplines. And on the right side, you have the different types of Swiss universities. You have on top ETH, which has on average better scores than, for instance, the smaller Swiss universities of applied sciences. So these are also factors to take into account. Now, if you put everything together, I'm summarizing all the results here. I'm very bad at describing numbers, but we have here a summary of first we can see that the perceived average score difference between international and Swiss-based reviewers is somewhere between 11 and 12%. The adjusted effect, adjusting for all the other factors that we've seen, is about half, and the same goes for applicant versus SNSF proposed reviewers, where instead of 13 to 14% an adjusted effect, you have an adjusted effect of 6 to 8% only. And the same goes to male versus female applicants and male versus female reviewers. Here the adjusted effects are much more, actually. So these are the main results, and thanks to these results, actually, the SNSF no longer allows applicant-proposed reviewers since 2016, and international reviewers are preferred over national ones to minimize possible sources of conflicts of interests. And of course, the SNSF also has designed a number of favorable conditions supporting women and families. Yeah. If you're interested in the topic and you want to know more about gender bias, I hope you saw François' poster. If not, you can just talk to him. And then you have tomorrow, if you're interested to know more about the different the different factors influencing the overall scores, please go see Stephanie's poster at Montreux tomorrow afternoon. And with that, I would just like to take the opportunity to invite you to follow SNSF's channel on science policy. And of course, thank you all for your attention. And I look forward to your comments and questions. Thank you.
Great, thank you. So, as usual, we have 10 minutes for questions, and if I was Drummond, I would say no speeches. I said it anyway. No, I was only looking in that direction. I'm not sure which of you was first.
Christopher Hayes in Kansas City. So if you look at the literature regarding somebody who's submitting a manuscript for publication and they suggest a reviewer, certainly there's data to support the fact that reviewers suggested by the author are much more likely to recommend that a manuscript be accepted than not. And that's what you're finding here. But I think most people tend to believe that those reviewers may be more valid than a non-reviewer suggested, non-author suggested reviewer. Obviously, you've concluded, or it seems like you would have concluded based on your actions, that an applicant for a grant who's suggesting a reviewer, that person is more likely to give a poor review. But do you have reason to believe that?
Well, I'm not going to talk about beliefs here, but well, the results are the results we saw. We used to check for obvious conflicts of interests. And of course, there's a trade-off. If I'm proposing someone, I'm expecting this person to be more engaged in the work I'm doing, and if there are no obvious conflicts of interest, it might be a very good suggestion.
Yet the recommendation is, or the action is, to eliminate those people from reviewing grants, which may not be a positive move.
And I think this is more a strategic move to engage more the offices, the SNSF personnel, to look for these people.
Okay, thank you.
Michael Mullins, Washington University in St. Louis. Given that there are 3 official languages in Switzerland, do grant applications come in only one language, or a language of choice? Four languages. My mistake. Do grants come in all languages or just in one? And would that influence either the propensity to request a peer reviewer who speaks your language or your preferred language, or does that influence the reviews?
Yeah, especially for social sciences and humanities, some grants might come in German, but I think there's a general trend towards English. And if it's a grant in German, it could be in French as well, but then you also have France and Germany talking that language, so it shouldn't be such a big problem. But yeah, that's definitely a problem. There's a general movement towards English, and as a data analyst, it's a nightmare to have all these different languages, actually.
Thank you.
Thank you.
Lisa Barrow, and that was so interesting, and after seeing your funding rate, I think there's going to be a stampede of researchers moving to Switzerland, so I just want to warn you that that's going to happen. But I noticed that the changes that were made in response to your findings were to actually drive your scores towards the higher scores. And I'm just wondering why, because that actually might reduce variation in your scores, and some granting agencies you would think would want more variation to help differentiate between higher and lower, quote, quality grants. So I'm just wondering, I mean, maybe a lower score isn't necessarily bad, as I think the other reviewer was, or commenter was indicating.
Right. By moving towards international experts, we lose the Swiss criticism.
Yeah, and also the other change, too, would move you towards higher scores.
No, the other one, it would be the opposite direction.
Ah, okay, I misread that then. Okay.
Right. Yeah, it's a problem, right? A problem of resolution. We have this problem when again, in 2012, we changed, or 2010, we changed the guidelines specifically to address that. It's not easy, especially if we get reviews from the United States of America. They tend to be very, very positive. It's not an easy
Thank you. Another question here.
thing.
I'm going to make an argument for less resolution. These scores are different across countries. People have very different anchor points, and they're a filter between the actual decision, which is should this grant be funded or not. So have you ever thought about getting rid of the scores and having should this grant be funded, yes, no, maybe, which is the system we all use for journals?
Right. That's a good idea, I think. But the idea also behind this course is to look at different components. And I invite you to go tomorrow to this other poster session, because you have to look at different things. And at the end, you come up with an overall score. Now, I agree with you, but then we still have 3 external reviews per grant. So, and I don't know, I think people like it like that, but maybe it would be better to have a binary decision on that. It would be a different system, but maybe it's a good idea.
Okay. And another question?
Me?
Yeah.
Thank you. Hi, I'm Elizabeth Seaver. I'm a researcher at PLOS. I was wondering about your linear model and how you chose which factors to include and to exclude. My guess is that age and gender are highly correlated, and so I'm wondering if taking out the age effect might be obscuring any gender effects.
Right. We also looked at interactions between the factors. So of course, we were interested in gender and these 4 factors mainly, and then we corrected for the remaining ones we had. And then there are interactions which we also take into account, but differences are it didn't change the final results. So we showed the results as such, but it's a multivariable linear model, very simple. Yeah.
Thank you. Actually, I have a question if nobody else does. This was all grants pulled together, so we can't see whether there were program grants or sort of young researcher tracks and all that kind of thing. But one question I thought was unresolved in your presentation was about age. It seemed to be that young researchers were somewhat discriminated against, and I didn't know if the funder was aiming to do anything about that.
Well, this is a program called project funding, which is the equivalent to somewhat equivalent to the NIH R01, I suppose. So it's for established researchers, and yes, we do have a problem with age, and that's another study of ours and another concern. And we do also have then specific programs for helping young researchers achieving independence.
Okay, thanks. Thanks very much. Oh, another question. Oh, 2 more questions. Right, we've got 2 minutes.
Mine, I think, is just a clarification. Aileen Fyfe from St Andrews. I've just been following the Twitter stream, and I've been wondering whether you've banned reviewers who are named by applicants, or whether you've just stopped asking applicants to name reviewers, but there's still the possibility that your office staff might pick the same people that the authors would have picked. Because there's a difference, I think. I thought you said that you're not actually banning some people from reviewing, it's just you're not asking authors anymore for recommendations.
Correct. Yeah, I think that's correct.
Thank you.
Thanks.
Thank you. Last word.
Before you start a stampede to Switzerland to get money, you should be careful, because the Swiss are very odd people. I got a grant from your agency about 30 years ago to do a study on Mont Blanc, the summit of, and filled a truck full of the necessary equipment, very heavy equipment, and after half an hour driving this truck towards the Alps, was arrested by the Swiss police for having too heavy a truck, and immediately couldn't get out of jail until I'd paid $1,000, and I still haven't got that back from your agency.
Well, I hope that money was invested into research.
Well, a very good start to the session. Thank you very much. Okay, so well done. Thank you. Swiftly on then. No pressure. We have Marianne Guadagno, who's going to be talking to us about stakeholder perceptions of peer review at the National Institutes of Health Centre for Scientific Review. Thank you. Oh, yeah, and you're going to present there because this thing is really tall. Yes.
Okay, thank you.
Thanks.
Thank you for your kind invitation to present results of our research on stakeholder perceptions of peer review at the National Institutes of Health Center for Scientific Review. I want to make a special thank you to Richard Nakamura, my co-author, who is so wonderfully here today and will be sharing additional research about our experimental evaluations immediately after me. Before I begin, I would just like to set the context for this research. NIH is part of the U.S. Department of Health and Human Services. We're the largest medical research institute in the United States, and we fund a great many different types of grants and contracts. CSR, the Center for Scientific Review, serves as a service center for grant review at the NIH to about 24 different institutes and centers that have funding authority at NIH. At CSR, we review about 75% of all grant applications that come into the NIH. We receive around 81,000 grant applications a year, and we manage the review process with only about 250 scientific review officers who are really wonderful in terms of managing these grant reviews. We typically recruit about 17,000 reviewers from the faculty across the country and sometimes across the world to participate in the grant review process each year. So as you can see, the scientific community plays an incredibly critical role in the peer review process, and we are greatly valued. We value their work and are appreciative of their many contributions to us at CSR and the NIH. The current CSR studies are committed to better understand the quality of the NIH peer review process. So just a few years ago, we embarked on a journey to gain a more comprehensive and systematic view of what our stakeholders perceive we do, and also how well they perceive the quality of what we do, the quality of peer review. Our goal for these assessments is to obtain actionable feedback, and that means we only ask questions if we can do something about the answers we get. The two major questions that were guiding this evaluation process were, first, to what extent are current CSR practices for peer review optimal for achieving our mission? And our mission is to ensure that all applications receive a fair, independent, expert, and timely review, free from inappropriate influence, and so that we can fund the best applications going forward. The second thing that we felt was important in terms of questions to answer were, what are the areas of success and improvement in the quality of peer review? So the first phase of this evaluation effort was conducting quick feedback surveys with two of our grant stakeholder groups, the NIH program officers and also the reviewers who come in to review the applications. We wanted a survey instrument that would be short. It would only take 3 to 5 minutes to complete. We wanted to minimize burden. We realize that many people are inundated with surveys these days. We consider them tools for helping us learn about service delivery from the stakeholders' perspective. We really wanted to reach out and find out what our stakeholders think of us. There had been several kind of piecemeal studies conducted over the years with a group of stakeholder, but there was nothing consistently done across a certain time and with all of the various groups that we work with. Our assumption for this quick feedback surveys was that reviewers and program staff are in a strong position to provide quality feedback about our peer review process. So the scope of this comprehensive and systematic effort was to really conduct quick feedback surveys, focus groups, and personal interviews with 5 different stakeholder groups. The quick feedback surveys were conducted with reviewers and program officers. We sent surveys via email with a personalized link to the survey. With the reviewers, we sent them out during the study section meetings. With the program officers, we sent them out after the review cycle. We did this in 2 years, really, 2015 and 2016. There was somewhat of an overlap in the time frame for the grant cycle, and that's why you see 2015, 16, 16, 17 in terms of the reviewers. We've reached out to over 10,000 reviewers each time in all of our 500 or so CSR study sections in one grant cycle. We thought we had an excellent response rate with 47% of our respondents responding to the survey. With the program officers, we sent them surveys at the end of the grant review cycle so that they could give us just one response, one survey, in terms of all of the study sections that they may have observed. And every program officer had responsibility for at least one CSR application before we would permit them to be a part of the survey. The response rate was 37 and 38%, which actually for us is quite good. We also conducted focus groups during this same time frame. We completed 27 focus groups with 4 different constituents: applicants, reviewers, scientific review officers across NIH, both at CSR and in our institutes, and also with program officers. And we conducted personal interviews, executive interviews, with half of all of the NIH directors. We looked at directors who had responsibility for smaller budgets, moderate budgets, and then some with very high grant review budgets. Here's a sample of the agreement statements that we used in the quick feedback survey. And I don't want to go through them individually, but you can read it. I just want to say that we used 7-point Likert-type scales to measure where reviewers and program officers agreed on 4 critical elements of peer review. On the scoring, the prioritization of applications according to scientific merit, on the roster of reviewers, whether or not the people that we assembled to review these grants were appropriate, on the assignments of the applications to the reviewers, did they make sense? Did they have the right expertise, broad expertise? And then also on the quality of discussion during the application review meetings. We used an open text box at the end. This is a very short survey. The program officer survey was a bit longer, and I'll talk more about that in a minute. But we asked them to tell us anything else that they felt was important for us to know, and we did get thousands of comments. We also gave the director's email address at the end of the survey and said if you have a personal question you would like to have answered, our director will answer it personally. All of the surveys were anonymous, they were confidential, and we reported back the results of these surveys to senior management within 1 week of the scientific meeting, so they knew instantly what reviewers thought of the meetings. And every year, we send the scientific review officers a summary of how they did compared to CSR overall, and we ask them to share that with their reviewers so that everybody is in the feedback cycle. It's important to note that when we do these feedback surveys, we stress with senior management and with SROs that this should not be a part of their evaluation at the end of the year in terms of their progress reports on how they're performing, but that they should be used as constructive indicators to help make what we do even better. Let me, whoops. Oh, 1 minute. Oh my gosh. Okay. Let me try to be quick.
That's really quick. quickly.
All right, very quickly. This is favorable responses. The first two bars are from our reviewers. The next two bars are for our program officers. Very quickly, you can see that our reviewers were much happier with what we do than our program officers, and these were the 4 dimensions of what we looked at. These are looking at alternative study section format, meeting formats, regular face-to-face meetings, teleconference, video-assisted, and internet-assisted on each of those 4 dimensions, scoring, rosters, assignments, and quality of discussion. And you can see that face-to-face meetings are by far the gold standard. Internet-assisted meetings are new. They're not quite as well accepted yet, but we're working on it. And video-assisted and teleconferences are quite favorable. We track the trends over time. This is a look at how reviewers rated us. The dark green and the lighter green are very favorable, 1 or a 2 on a 7-point scale. Program officers, we asked about some of the issues they were concerned with in 2 years. Orange is 2015, green is 2016. You can see that there was some improvement in their ability to hear our meetings. Most of them dial in, so there have been some technical challenges. They tell us about the quality of listening. There's also real-time status is kind of a triggering device that tells the program officer when an application is coming up for review, a scheduling situation. You can see that got a little worse, but we are working on it. Travel to meetings. We now conduct study section meetings across the country, not always in Bethesda, but program officers, some are not happy with that. And internet connectivity is an issue that we have to kind of deal with. Focus groups results, I just want to consolidate into 2, a positive and a negative kind of a challenges statement. But in terms of the positive, we got thousands of responses. We use computational linguistics to get at some of the trends that are coming through in real time. And we would have to say that the current system is fair, rigorous, and like democracy, flawed, but the best available. Some of the challenges we saw have been issues of bias against certain types of research. Some feel that we don't have enough recourse for reviews that are considered inaccurate. But these 2 things are very important for us to know, because we actually do have recourse for reviews. So we need to be better at reaching out and educating. And I think I have to stop right now. Thank you very much.
I know you have one more slide, so let's look.
You want to look at the
I can
one
see how many slides you've got, yeah.
So what are we trying to do to respond to these? As I said, we only ask questions if we can get actionable results. Richard is going to talk about some of our alternative scoring methods that we've been introducing. We have a massive study going on right now determining whether bias exists in peer review. We also have looked at scoring distributions across study sections, and where they seem to be outliers, we're thinking in terms of realigning so that the study sections are more in sync with the applications. And we're working on some technical issues that I won't mention for our program officers to help them listen better. But one of the major complaints we get is the issue of pursuing the homeostasis of glucose and caffeine. And by that I mean about 5 years ago we were told we could no longer serve refreshments or coffee at study section meetings. And Richard continues to push and help us in that effort.
Okay, thank you very much. There's a lot to cover.
Much.
Thank you very much.
Hi, Steve Gallo from the American Institute of Biological Sciences. And I just had a question related to, do you have any data, similar data of applicant perceptions of peer review, particularly with regard to expertise? And do you have anything, or would you plan on doing anything in a paired way, so you could look at the applicants paired to the same peer review panel to see if the perceptions are the same or different, or how different they are?
Thank you, Steve. That's a great question. The data that we have from applicants is anecdotal data in focus groups, and there were quite a few focus groups conducted with the applicants. We did it in 4 different geographical areas because we have our chartered slates. We invite reviewers in based on geography. So we do have those data available, and I can share some of that with you if you would like after the meeting. In terms of looking at applicants, we asked similar questions in these focus groups. We really spent a lot of time working on the moderator's guide so that we could get somewhat of the same perspective from the different stakeholder groups. So we do have extensive data from focus groups, from applicants, from reviewers, but not in the same meetings. And also from our program officers and scientific review officers, but I like that idea very much. Thank you.
Thank you. We have a question from Facebook, but first I'll take the question up here. Thanks.
Actually, mine is a bit of a follow-up to the last question. And, you know, you mentioned the idea of stakeholders, and certainly the applicants are a major stakeholder in this process. And whether or not you could implement some sort of a standardized electronic evaluations tool post-review once the applicants have received their reviews. I think that would be very interesting to the scientific community.
That would be very interesting. We haven't discussed that, but we'll certainly take it into consideration, and it could be done. One thing I would just like to mention that you may already know, we do have constraints with the budget right now at NIH. So about anywhere from, I would say, 70% to 90% of our applicants are going to be unhappy customers in that a lot of excellent grants just can't be funded because of the budget situation right now. But I still think that's a valuable suggestion, and I think it would certainly be interesting to talk with applicants after the review.
The focus group suggests that about 80% of the variance in the responses will relate to the score that the individual received.
Right. Thank you, Richard.
Okay, thank you. You mentioned the budget, so it's a good time to ask the question from Salman Tahir in Lahore, Pakistan. And the question is, at what percentage are you funding?
It depends on the institute that has the programmatic responsibility for funding, and some of the institutes can share funding. But Richard, would you say it's, Richard is our
The number NIH
authority.
is using is the success rate overall is 18% right now. But the institute rate goes from success rates of 30% to a little less than 10%, okay, depending on the institute.
So everybody has to move to Switzerland.
Thank you.
Yeah. Okay. Thank you. And a question here.
I wanted to refocus the first question back on the reviewers, because at least anecdotally, that seems to be a major concern they have about being assigned applications that are really outside their expertise. And I wonder if there were differences in perception among the SROs and the reviewers, or whether even that question was addressed in your survey, and what sort of responses you got.
It was addressed to the reviewers, and we did ask them if they felt that the assignments were appropriate to their area of expertise. And over 80% said yes. But we have heard anecdotal comments, certainly, and comments through the focus groups to address the issue that you're talking about. And I would have to say that most of our SROs will go through great lengths to try to change an assignment. If a reviewer gets an assignment, says this just isn't right, they call the SRO will try to make an immediate assignment switch. So yeah, I mean, there's some of that definitely going on, but we do make every possible attempt to make sure that the applications are appropriately assigned to the reviewers. And we were pleasantly surprised. I mean, when we asked the question to reviewers, this is over 4,000 responses. They said that over 80% of the time, the assignments are good.
I too am a bit surprised just based on my own perspective. So I wonder whether there are areas that do very well and areas that don't, and some of them, there's often difficulty finding appropriate reviewers.
Yes.
And ones that are not conflicted.
Right.
And so maybe a deeper dive might help you focus that.
Right.
Thank you.
No, thank you very much. And we also, from the comments that we get from the reviewers in the study sections, we can't go study section by study section, but we do look at it from an institute perspective, and if there appears to be issues like the one you raised, Richard will go and personally speak with the institute director and try to work things out. What kind of expertise do you need? And do we have it, and do you have suggestions for who might be good? Thank you.
Thanks. I have one quick question, which is, you had very large numbers of respondents in your surveys, but you had a potential for quite a large non-response bias because the response rates were quite low. So I just wondered if you'd thought about doing a stratified random sample of reviewers in each of your areas rather than trying to get everyone.
Right. Now, we could do a stratified random sample, and I think that's a really good idea, and we've discussed that. But the issue is, if we really want to get at the study section level, there are about 500 study sections in one grant cycle that get reviewed. In order to give the scientific review officer accurate feedback, we really need to reach out to the community. Otherwise, our ends could be very small for the study section. But it's a great idea, I agree.
Oh, well. Thanks. I think that's it for questions. So thanks very much, and we're still on time. So great. Thank you. Yeah. So now we have Richard Nakamura, who's going to tell us more, and this time on testing of 2 application ranking approaches at the NIH Center for Scientific Review. Thank you.
Thank you very much. I appreciate the invitation to come and even the pressure Drummond put on me to make an appearance. I wanted to tell you about a couple of intervention experiments that we have done to try and see what a change in our scoring process, what effect a change in our scoring process would have on our ability to rank applications. I'd also like to say about conflicts, though nominally I don't have any conflicts, I am employed by the federal government, and that probably influences my perspective. Now, quickly, for the current system, which you've heard part of, I won't repeat all of these things, but applications are assigned to 3 reviewers who provide preliminary impact scores using the whole digits 1 through 9, and they provide critiques. After a panel discussion of each of the top 50% of applications, all panel members vote on a final overall impact score. Each application's scores are derived from the average of all panel members' votes and multiplied by 10, resulting in final scores of 10 through 90. R01 applications, the R01 is the basic grant application for NIH, are assigned a percentile based on the scores of applications reviewed. Now, this is the distribution in 2016 of our R01 grant application scores across 3 review cycles. The overall number of scores is over 32,000, so we have a pretty high level of accuracy here. And you can see that this is a skewed distribution, and in which of the discussed applications, so the scores are naturally skewed towards the good end, 10 being the best score, 90 being the worst. The interesting thing about this is that the scores are of 10, 20, 30, 40, and 50 have very clear peaks, with the absolute score of 20 being 4 times as high as the scores for 19 and 20, or the related next door scores. So this is shows a problem of both grade inflation and grade confusion at these 10, 20, 30, 40 levels. So we're looking for an approach which would help differentiate grant applications further, and we tried 2 different approaches. So one, we tried a rank order approach, and the potential advantage is reviewers are not forced to give applications higher or worse overall impact scores than they think the applications deserve. They also, reviewers are required to distinguish between applications of similar quality and separate the very best from the rest. And reviewers have the opportunity to re-rank applications after hearing the discussions of all applications, something which we can't do in the current system. Some disadvantages are that applications cannot be ranked with respect to applications in the previous 2 rounds, as is done in the percentile system. And reviewers in study sections that cover highly diverse scientific areas may find direct ranking more difficult. Also, if at the end of scoring they do private ranking in the 1 through 10, through 1 through 10 ranking, that may lack the transparency of the current system, in which reviewers who vote out of order, out of the range set by the assigned reviewers, must provide a justification during or after the discussion. So there's more transparency about how each of the reviewers are voting on each application in the current system. That could be covered up in a ranking system. So we decided to do a pilot study in which a ranking was tested against the current system. So it's carried out in parallel with the current system in 2014 and 15 council rounds. Applications were scored as usual, and reviewers were asked privately to rank their top 10 R01 applications in order. And ranked data was analyzed for informational purposes and not used for funding decisions in this case. So we had a lot of discussion, and I'm open to suggestions on how we can better display the data. This is to simply show the proportionate scoring compared to the percentile bins of a given application. So the ranks are on the left, and the percentile bin is at the bottom, with about 70% of the votes for rank of 1 held within the 0 to 5th percentile. You can see that there's quite a good consensus around the first 2 or 3 ranks, as there is with the current percentile system. But as you move up the ranks, there is a much less agreement about what is the best application within a group. Just to make it a little bit easier to see this, you can see this in percents. So 70% of the vote for the first best application was within the top 5 percentile points. And then this goes down to, at the 10th rank, about 18% of the votes were in the 15th to 20th percentiles. This will be a score good enough for funding in some institutes and clearly not in others. What about doing it in another way? And this was suggested by a number of reviewers about adding a half point for scoring, and the reviewers were asked for more scoring flexibility than 1 through 9, and asked that they have available an extra half point. The ability for reviewers to score application with half-point increments may spread scores and allow reviewers to score more precisely to reflect their opinion. However, if we simply allowed the original scoring based on additional half-point increments, we already know that the scoring would again be re-squeezed into the lower quarter of the voting segment. And so we did this in the final vote. All reviewers were allowed to be within the range of the original scorers or reviewers, but they could freely, without declaring it, add or subtract a half point. So that's what we tried, and this was the result. Essentially, what happened is there was a considerable decline at the absolute scores from 10, 20, 30, 40, so that at 20, rather than 4 times as high for the score of 20, it's about double the height of the 19 and 20. And then at 30 and 40, there's a very tiny increment over the general range of other related scores. These curves relate to slightly more than 700 reviewers across about 15 study sections. So this does not, it's a much noisier curve than the others. I'm sorry, 39 study sections. How did reviewers feel about this? I should have used the green and red system that we used in our other cases, but the orange and blue sections are the agree and slightly, very much agree and agree, pink being slightly agree. And you can see that the quality of the prioritization, a majority of the reviewers thought was positive, and but not as strong as the original face-to-face kinds of evaluations. Scoring accuracy, they thought was better, closer to 70% agreed. Reviewers are conservative. They generally don't like to change systems. What we was striking here is that in this case, they called for a change in policy to allow them to more systematically use this score. And we are planning on doing more testing of this to see whether or not we should change our policy. That's it.
Great. Do we have any questions? Looks like there might be one coming. Good.
Well, let me just say I'd really appreciate having any discussions later here with any of you who would like to discuss NIH grant policy and peer review and any ideas that you have about how we should think about changing peer review. Thanks very much.
Thank you. Well, actually, I think we have a question, so do stay at the podium, because there's one here. I was going to say, you've opened the floodgates now. Oh, no, here we go.
Well, bravo for doing a study. This is great to actually see different scoring systems tested side by side, because the big problem is we have no gold standard, which is very hard, so we're comparing 2 systems and we don't know which is better. So one idea is to include grant applications and seed them with, well, insert deliberate mistakes. Make some grant applications deliberately bad. Put them into your round and see if the reviewers can actually spot them. Then you do have some kind of gold standard mixed in there.
Yes. We are, this is a little bit like a reliability check, and we are, within the anonymization study that we're planning, we will end up getting at least 6 independent reviews of full grant applications, as well as anonymized versions of those applications to see whether or not factors like race, ethnicity, geographic region, other factors, seniority, affect the outcome and scores, gender as well.
Could I just ask what sort of error you were thinking of? Because, in fact, Fee Godley and others at the BMJ did a study by inserting errors into papers to see if peer reviewers pick them up. But then you've got results, you've got study results, and there's scope for having errors. But with a grant application, you've got study methods. So I wonder what kind of error that you would think of inserting, just briefly.
Wrong cell line, terrible sample size calculation, not citing the literature properly, a study that's already been done.
You're expecting a lot from the reviewers, I
suspect.
If you think they're going to spot things like that. But anyway, I'm really intrigued. Thank you. Food for thought for all of us, I'm sure. Thank you.
Hey, Scott Lemire from Baylor College of Medicine. The currently early stage investigators and new investigators get a bit of a bump in their overall impact score. What was sort of the plan for managing that in the rank system? Would there be an automatic move up in rank, and if so, how many points? What was sort of the translation going to be for the ESIs and the new investigators?
Yeah, though we cluster those, we don't actually call for a difference in scoring. We just call for them, reviewers to take into account difference in seniority. We have not planned on making any change. What the institutes are doing is actually funding a higher proportion of those so that the success rate of those individuals is equivalent to that of more senior investigators. So the actual compensation occurs at the institute level at the award stage.
Thank you. And there's one last question there, I think.
So, Brooks Hanson, I'm wondering if you're in trying to quantify what is inherently partly subjective process and driven by systematics in who's selected to review, perceptions, and so forth, that the noise, the inherent noise is larger, which is the fine distinction between fairly good grants that are on the bubble, is well beyond any kind of signal quantifying point system, whether it's a 5-point scale or a 20-point scale or a 1,000-point scale.
Certainly, I would agree that the system is very noisy, especially when you have 3 primary reviewers. We are looking at the potential for systems that would produce higher numbers of reviewers. The current system for funding applications makes that difficult, but we have thoughts about possible solutions. I won't go into it right now, but
you have a couple of minutes if you'd like to.
So one of the things that NSF has been doing is applicant reviewers. So they've tried to see whether or not they could do in a fair way having applicants of a round be the reviewers of that round. If we gave such applicants, if we could solve the conflict problems and gaming problems, those applicants would have the right expertise within clusters, and a reasonable workload would be 7 to 10 applications. That means that each application could get 7 to 10 reviews. I think that would give us a lot of information about reliability, about how to look at scoring, and I think this is an interesting idea that we should try.
Okay, thank you. And there is one more question. In fact, we have a minute or two.
Misha Teplitsky from Harvard. I've seen a little bit of work suggesting that ranking versus rating tends to favor different kinds of applications around innovativeness. I wonder if you've seen anything about, if you see a different kind of application getting selected.
So the same applications are selected for the top 3 or 4 positions. After that, it gets very different across reviewers. So, and we even see things that were originally scored 60th, 70th percentile suddenly coming up in rank. So it's created a lot of information that we don't quite know what to deal with. So if any of you have suggestions or ideas that you'd like to discuss, come and see me.
Okay, thanks very much. So we've had a lot of health research or research in areas of biomedical publishing, but we haven't heard a lot about the role of patients in peer review and grant review until now. So good timing. So now we have Laura Forsythe talking to us about scientist, patient and stakeholder roles in research application review at PCORI.
Thank you very much. Good afternoon, everyone. It's a real pleasure to be here to wrap up this panel, and I will try to keep it interesting because I know we're getting very late in the afternoon at this point, but I do think this is a fascinating topic, so I'm thrilled to share it with you. I just want to highlight that myself, as well as many of my co-authors, are either current or former staff of PCORI or members of PCORI's Methodology Committee or Board of Governors. So you heard a little bit about PCORI earlier today, but I want to highlight that we were authorized as a funder of clinical comparative effectiveness research in the US in 2010. And PCORI's mission really is to improve healthcare decision-making for patients and those who help them make decisions. And we aim to do that by involving patients and the broader healthcare community in everything that we do, including review of applications for funding. So PCORI's merit review of applications is unique in two really important ways: the involvement of patients and other stakeholders as reviewers of every application, as well as a set of unique review criteria. So as part of a larger effort to evaluate the impact of PCORI's approach to reviewing and funding applications, this specific project aims to assess the contribution of different reviewer types to funding final review scores and funding decisions, and also to assess the relative importance of the PCORI review criteria. So I'm going to tell you a little bit more about PCORI's review process. I do want to note that there's been some changes over time to the review process for specific funding opportunities or more recently, and I'm going to be telling you about the process that was relevant to the proposals that are included in this project. So PCORI recruits reviewers into three different roles: scientists, patients, which also includes caregivers and advocates, and then what we call other stakeholders, and this includes roles like clinicians, health systems leaders, insurers, and others. And there was 5 review criteria: impact of the condition on the health of individuals and populations, potential of the study to improve healthcare and outcomes, technical merit or scientific rigor, the patient-centeredness of the study, and finally the plan for engagement of patients and other stakeholders in the design and conduct of the study. And scientists were required to score all 5 of these criteria. Patients and other stakeholder reviewers were required to score the potential to improve healthcare, patient-centeredness, and engagement. So I want to help you understand our review process a little more. Applications come in and they go through a preliminary online phase where every application was reviewed by 2 scientists, 1 patient, and 1 stakeholder as a primary reviewer. And each of those reviewers gave criteria scores as well as an overall score on a scale from 1 for exceptional to 9 for poor. And then based on that overall review scores from that online phase, about the top half of applications go on to be discussed at an in-person panel discussion, where again, the panels are made up of scientists, patients, and other stakeholders at a ratio of about 2 to 1 to 1, and everyone on the panel gives each application a final overall score. Ultimately, funding decisions are made by our Board of Governors, which is a multi-stakeholder group. Those decisions are based heavily on the merit review input, as well as other factors like our organizational priorities and programmatic fit. So this particular study is a retrospective cross-sectional analysis of administrative data from the review process from 5 consecutive review cycles that happened 2013 through 2015. And we tested associations between the final overall scores and the criteria scores given by each reviewer type using linear regression models, and they were stratified by reviewer type. So we tested 3 separate models. We also tested associations between the funding decisions, yes, it was funded, or no, it wasn't, and criteria scores using a logistic regression model. And all of the models adjusted for aspects of which funding program the applications went to, the review cycle, and characteristics of the principal investigator in terms of their experience. So I'd like to share some descriptive statistics with you. This analytic sample includes 1,312 applications that were reviewed in the online phase by a total of 535 reviewers. For the overall score in the online phase, scientists rated the proposals slightly poorer than the patients and stakeholder reviewers. 635 of those applications were discussed at the in-person panel, and ultimately 121 of them were funded. The final overall score was 28 for funded applications on average, compared to a mean of 50.1 for the unfunded applications. Before I tell you about the findings from the linear regression models, I want to take a minute to tell you about changes in the overall review score among the preliminary reviewers. Across all reviewer types and all applications, there was a change in the overall score from the online phase to the final score in 56% of the cases, and it was a change of 2 points or more about a quarter of the time. Most of those changes were towards a poorer score, and while the mean change is larger for patients and stakeholders compared to scientists, at least 50% of each of the 3 reviewer types the score changed at least 50% of the time across all 3 reviewer types. And we find through a different series of analysis that agreement converged after the discussion across reviewer types. And so the details of that are beyond the scope of this brief presentation, but I think this is some important context to interpret the models that I'm going to share with you. So, I want to explain these linear regression models. I want to set it up because it's a little complex. On the right, you see 3 boxes that represent our 3 linear regression models, one for each reviewer type, and the dependent variable here is the final overall scores among reviewers of that type. And on the left, you will see boxes representing the criteria scores as scored by each of our 3 types of reviewers. Now, the details of these models with the effect sizes and p-values and all of that are in the program, but I want to focus on the main takeaways here. First, these arrows represent the significant associations across the 3 models, and there's 3 points I want to highlight. The first is that for each of our 3 reviewer types, their final overall scores were related to 1 or more criterion scores from each of our 3 reviewer types. So to say that differently, there's an arrow of every color, all 3 colors, going into each of the 3 boxes on the right. So there's a lot of associations across reviewer types here. The next thing I want to highlight that isn't showing up well on this screen is that the strongest predictor for each of the 3 reviewer types is technical merit as rated by the scientist. So the strongest factor in all 3 of our models was the scientist rating of technical merit. Oh, there it is. Well, this one works better. The third point I want to make is that all 3 reviewer types' ratings of the potential to improve healthcare and outcomes were important in all 3 of these models. And lastly, when we look at our logistic regression model to identify the criterion scores associated with our funding decisions, we have a similar setup with the criterion scores on the left here from the different types of reviewers. And these are the factors that were significant in the model. So each of these criterion scores were positively associated with the likelihood of being funded. And those were the scientist rating of potential to improve health. For some reason, it's covering up the second box there, which is technical merit as rated by the scientists, and the scientist rating of patient-centeredness. And then also significant were the patient and stakeholder ratings of the potential to improve healthcare and outcomes. And there's 2 things I want you to take away from this model, and that is, again, that there are ratings from all 3 of the reviewer types that are significant in this model. And secondly, again, the importance of all 3 reviewers' perceptions of the potential to improve healthcare as important in these models. So there's some limitations to highlight to help you interpret these results. Although PCORI assigns people into one of 3 reviewer types, we know that our reviewers often identify with multiple roles within one person, making it difficult to attribute the contributions of the review process to any one viewpoint. And at the time of this study, the patients and stakeholder reviewers were not required to score the technical merit and impact of the criterion, impact of the conditioned criterion. So we know less about their individual views on those concepts. And our regression models can't tell us about causal relationships, although they do help us identify important associations. And we can't identify every factor that goes into determining the funding decisions, because as I mentioned, it's really a constellation of factors heavily based on the merit review process, as well as other factors like programmatic fit. And finally, when we think about generalizability to other review processes, we need to consider differences in approach across funders and across time. That being said, there's some important conclusions that we draw from this research. The PCORI merit review process brings together reviewers from diverse perspectives, and they help us identify the applications that best meet our criteria in terms of technical merit and also potential to improve healthcare decision-making. And we learned from these analyses that all three reviewer types contribute to the review scores and funding outcomes. We see that technical merit is important to all reviewer types and is critical to funding success, as is all three perspectives on the potential to improve healthcare and outcomes. And taken together, this information helps us determine that research application review can usefully incorporate non-scientist views, particularly when we're looking at near-term indicators like the application scoring and the funding decisions. Ultimately, our understanding of the impact of PCORI's approach to merit review will be in assessing the impact of these studies that we fund, particularly in terms of the speed of uptake of the findings into clinical decision-making. Thank you.
Thank you very much. Yeah. Right, do we have any questions? We do. Great. Hi.
So this is a question for both the current speaker and the one from the NIH. Sorry, I forgot your last name. So, so we talk a lot about how the results of the founded research were being utilized and reported, and I wonder if there's any plan to incorporate some of the things that we discovered. For example, some of the sponsors routinely do not publish papers or routinely do not report results, and incorporate that into the decision of funding process to ensure that this becomes incentives. And what if you show patient that most of the research that you are participating in, or whatever the patient involved in the research, will not be utilized or shared? How will they feel about that?
Mm.
Yeah, that's a great comment. Thank you. And one of the things that PCORI is ultimately looking towards when we're talking about impact is to whom and how the results are disseminated, and going beyond just the scientific community. So dissemination plan is part of the overall research plan of the applications that were reviewed for this process. And so I think it's an important place where our patient and stakeholder reviewers do weigh in on that.
Although I think that is important, but I think the question was also pointing out the idea that if people hadn't played ball previously because they'd done a study funded by PCORI, but then they hadn't bothered to register the study, they hadn't shared their results and all of that, that you would penalise them this time round by saying, sorry, you didn't do it right last time. So are you doing anything along those lines? I think that was...
Yes.
That was yeah.
Yeah, thank you. And a relevant point here is that PCORI was authorized in 2010. We held our first review meetings in 2012. And so these awardees that we're talking about actually, at least for their PCORI study with this approach, very few of them have yet had the opportunity to demonstrate what they will do with the PCORI funds. So it is something that we're looking to in the future. And I will say part of our authorizing legislation as well is that all of the results of our funded studies are made available within 90 days of completion. And so PCORI has a translation center where, regardless of whether they're positive or negative results, those will be made publicly available. So PCORI has a role in that process as well.
Okay, great. So suddenly we have 3 questions.
Well, let me just say quickly about that, since the question was addressed to NIH as well, that a major part of the rigor and reproducibility initiative and the clinical trials initiative, which will start in January, is to ensure that the clinical trials are brought to completion with a publication and registration on clinicaltrials.gov. So NIH is dealing with this problem.
Thank you very much. Thank you. Okay, we have 6 minutes, 4 questions, hopefully some answers. So you're going to have to make it snappy.
Okay, I will restrict this. I actually had a few questions, but I'll restrict this. So technical merit affected all reviewer types, but only the scientists were actually rating technical merit. So was that affecting it before or after they got the input? In other words, did the 2 other groups change their grading of this particular grant after they heard what the scientists had to say about it?
Yeah, so we don't know what in particular might drive people to change their overall score from the online phase to after the in-person discussion. But I suspect that is one element, because the 3 groups, after they score the proposals independently on the online phase, come together, and one of the things they heard was the scientists' explanation of their rating of technical merit. And so I think that's one way in which we see how people value that input and put it together with some of the other criteria, is the change of scores from when they scored alone to after the discussion.
Okay, yeah, both in that mic there, yes, and then.
Theo Bloom, BMJ, and a quick question from Twitter and for those of us jet-lagged in the room. I think you talked about scores getting lower after discussion. Was lower good or bad?
They move generally to be towards a poorer score after discussion.
And at NIH, when you said the scores were bunched together at one end of the scale and not at the other, were those good scores or bad scores?
They're bunched at the good end.
Okay. I think there was some confusion about which numbers meant which. Thank you.
Thanks. Yes. Okay, and then it was, and then.
Guadagno from Bosnia and Herzegovina. I was wondering about the patients. Are they suffering from the disease, or they are a general patient population?
Great question. So the patients on the panel will represent a variety of groups. One thing that's an opportunity and a challenge with PCORI's merit review compared to a study section in NIH is that our review panels are covering a much wider range of disease conditions, therapeutic areas on any one panel. And so the review group does their best to match up applications to people who are affected in some way or might be affected by that condition or a similar one, although there's certainly some matchups where the patients might have a more similar condition than the exact one of study. But these are people who have the condition, are at risk of the condition, or maybe care for someone with the condition.
Thanks. So there is time for the last question. Great. Thanks.
Evan Mayo Wilson, Johns Hopkins. I think PCORI's done a tremendous job of raising the importance of patient-centeredness in research, and my question is whether having a few people involved in the grant review is really enough to do what we want to be done here, which is to generate outcomes and things that really matter to patients, and whether you've considered going further and saying, for instance, if you're doing a clinical trial, you should use a core outcome set or demonstrate that one isn't available, or use other methods to more systematically include patients in a broader and more representative way.
Yes, thank you very much for the question. What I didn't get into here is the role that patients and other healthcare stakeholders play beyond the review of applications. So you heard that one of the criteria is the plan for engaging patients and stakeholders. So every project has various approaches, but involvement of people who are affected by or treating or managing the condition involved in planning and designing the study. I think a key way that we're learning that those partners are affecting the contribution of the studies is in selecting the outcomes that will be studied and the ways that they will be measured. So one of the things that PCORI is doing is looking at what outcomes are measured in our whole portfolio of studies. I think it will point us in the direction of some core outcome sets. I think maybe that's the future once we have a robust portfolio of studies that have had patients and those who are caring for them involved in the design. But you're right, it's much beyond just the review process. It's in setting up the studies, it's in disseminating the findings, and ultimately in feeding back to PCORI how we can go about doing this whole enterprise a little differently.
Great, thank you very much. Thank you. And thanks very much to all of you, great questions. So we're out of here, next session. Thank you. Thanks.
Next, we're going to hear from Steve Goodman, which is really good at this late hour in the afternoon because Steve always wakes us up, I know, at our Annals meeting when we hear his booming voice coming from across the country over the phone. So for those of you who don't know Steve, Steve is at Stanford, where he is Associate Dean of Clinical Research, Chief of Epidemiology, and because that's not enough, also co-director of the Metrics group, which stands for Meta Research Innovation Center. He's also the vice chair of the PCORI Methodology Committee, very relevant to the presentation we just heard, but most relevant to me, and I think to the topic of this presentation, is that Steve is marking his 30th year as a statistical editor at the Annals of Internal Medicine, where I'm currently editor-in-chief. He apparently started when he was in kindergarten, I think. So without any further delay, let's hear Steve's going to tell us how to get SMARTA, which is something I think we all probably want to do.
Oh, that's the light. That doesn't work. Oh, there we go. Okay. Doesn't do any good to talk into a light. So we are going to talk about statistical review in biomedical journals. I appreciate fantastically that so many of you stayed this long. I expected to see the Hurricane Irma effect of, where this ocean receded, right before it came in, and all of a sudden, area you thought that was covered was bare. So that hasn't happened. So I will tell you ahead of time, this is not a 30-minute talk in adherence to the principles and spirit and principles of this conference. I'm going to try to make it half that time with the other half for discussion, and therefore there are a lot of things I could say that I won't, which I'm sure will come up in the discussion. My goal in this talk is both to report on the results of some research we've just started, but also to get Howard Bauchner to concede that SMARTA is at least as good an acronym as Yoda. So we'll see if we succeed in that. Well, you don't know. But I'm not going to tell you what it means till the very end, so you have to stay at least that long. So this is work that's been done with two folks. One is Tom Hardwick, one of our new postdocs, and Dan Finelli, our senior scientist. There they are. You're going to see Tom again in this talk, and you will see him around the meeting. So let's just start. What do we know about the use of statistics in the biomedical literature? And the fact is we know a lot. I'm not going to review all that here today. There are many, many, many reviews of the use of statistics, particularly specific techniques, but also generally in various specialties or in various journals. And they all almost universally show the same thing, which is there's widespread misunderstanding, misreporting, misapplication, misuse, miscalculation, and misinterpretation of statistics in the biomedical literature. That is the subject of a very long talk, a very fun talk, but that's not what we're going to talk about today. But I won't resist showing at least one of the reasons for it. So this is a paper done at the home base of Yoda, I will say. And it's one of an industry of such papers in which medical residents are who become the investigators, and they're the readers of the journals, are assessed as far as their own statistical knowledge. I actually think there should be a law against this. I mean, we can't experiment on medical students or prisoners. Why should we be able to do this to our residents? And I also don't understand the motivation. Well, why is it, how is it in our interest to show that our own trainees actually don't know something that we're supposed to be teaching them? But anyway, the point of this is actually not what they did or didn't know. They didn't perform very well, but they never do in these in these papers. But there was a certain irony here in that while 59% of the surveyed residents were reportedly chose the correct p-value definition, but none of the definitions in the questionnaire were correct. And this was in the supplemental materials if you wanted to go look. There were no correct answers that they were offered. So that says something about the use of statistics. Now, with p-values, maybe that is forgivable because, as 538 has shown us in a little video that you should all look for if you haven't seen it yet, not even scientists can easily explain p-values, and this is the reaction of about 10 different people who were asked, including many people in the room, to explain what a p-value is. So, that definition is perhaps excusable, but the point is that there are a lot of basic principles that are not understood by the very people who are doing the research and reading the research. And this is one of the elephants in the room, which we'll talk about more in a minute. But what do we know about the use and effect of statistical review in the medical literature? So we know a lot about misuse of statistics. This is one of those remedies. And the fact is, we don't know a lot. There are a few before-after studies. There's actually one RCT out there at medical clinics of Barcelona. I'm completely conflicted on that because it turns out that they use something they called the Goodman scale. I never created something I called that, but they used a scale we used at Annals of Internal Medicine once to assess the effect of editing in general, and they showed a small effect. There was another before-after study at the Croatian Medical Journal that showed that it had very little effect because basically the editor ignored the comments of the statistical editor. There are a few articles describing statistical review processes at individual journals like Lancet, New England Journal, and Annals, and of course we had two abstracts here today, one from the Annals and one from the American Veterinary Association Journal. The Annals one showed that even though folks had to work, conceded that they worked incredibly hard to address comments, that they weren't that unhappy about it. Now, this was all authors whose papers were being accepted, by the way, but they thought it was worth the effort. At the Veterinary Journal, unfortunately, they experimented with the process and they abandoned it because the logistics were just too tough and it extended the review process too long. So there have been a few surveys of the use of statistical review, and that's actually what I'm going to be talking more about today. One by Stephen George in 1985, then another one by myself and him and Doug Altman. I think that we presented at one of these congresses in 1998, and now another one that we've just initiated that I'll talk about today. But I do want to talk a little bit, just mention some of the literature on statistical reviewing. One of the best papers, still, this is about 20 years old, is from Doug Altman, which is an amazingly thorough discussion of all the issues and compendium of, at that time, the assessments of the of articles in the medical literature. And he has a particular quote that I enjoyed, which is, the difference between medical research and agricultural research is that medical research is done by doctors, but agricultural research is not done by farmers. And it's amusing, maybe a little bit insulting, but it addresses what's really, in a sense, the elephant in the room of many of the things that we're talking about, which is that the research is being done by folks, many folks who are not trained in research. Or if they've been trained in research, they've had very little training. They have not had the years of training of others, and sometimes typically those who get PhDs to do research. And this is a big, I would submit that this is one of the reasons that we're struggling with many of the issues that we're struggling with. And you can't substitute training in research or training in statistics with checklists or better review or different scales or anything. Those are important. Those are critical, but the heart of scientists is done by well-trained scientists. And this gets at the point that most people who do this research are not trained in statistics, although increasingly, certainly over the last 20 years, they have access to very powerful statistical software. Now, the very first, one of the very first, I don't know if it's literally the first, articles on the statistical review, it was done in JAMA in 1964. So this is over 50 years ago, and I'm just going to read you 2 paragraphs from this because they're unbelievably prescient. And they're almost as true today as they were then. Well, so the first one is actually the last of 5 reasons why he said that statistical research was important. Statistical review, he says, 5th, since with the introduction of computers, you can tell how long ago this was, with the introduction of computers, much work is being done to make the results of studies appearing in medical journals more accessible to physicians, so a considerable amount of misinformation could be disseminated rapidly. How different is it today? And then in the next paragraph, he said, in September '64, the editor of one leading medical journal agreed to institute a statistical evaluating procedure for manuscripts submitted for publication. Communications judged acceptable medically were subjected to the same type of critical reading as was used on the studies described in the first part of this report. And he goes on to describe the outcome of this procedure. And as you well know, many journals still do not institute a procedure like this. But let's fast forward to the project that we're actually going to be talking about. And this is a survey that we've been initiated to, in a sense, extend and expand the survey from a number of years ago, which is a survey of the use of the statistical review and statistical review processes across biomedicine and psychology. So what we did is we took the top 5 impact factor journals from all scientific fields within biomedicine, which is 68, and 14 in psychology, which turned out to be 441 journals. And we did this just in the nick of time for the Peer Review Congress. Thank you for scheduling it at this time. And we have 103 journals responding at this time, so you're going to get the interim results, as we talked about yesterday, of 82 biomedical, 21 psychology journals, and representing 56 unique fields. So some of you in this audience actually may have been solicited for this review, and if you're in the 300, 20 that have not yet responded, you've already gotten this reminder from a very friendly Tom Hardwick. It's a very polite reminder, and I'll just request that you avoid reminder number 2, because that's going to be sent by this guy. It won't be nearly as polite, but if you send it in, then you'll get a smiling Tom and a very friendly thank you. So we'll very much appreciate not having to deliver it with the first representative of our project. So here are the results. So the first question we ask is, what percentage of published articles, this is of published articles, have been statistically reviewed? This is a dot plot. And what you'll see is quite a range. And 27%, since there's 103 journals, 27 journals, say that they have reviewed all of them. And by statistical review, this is what we have in the question. We mean any technical assessment of the presentation and analysis of quantitative information that is performed in addition to traditional subject matter peer review. So that's how we defined it, or that's what we said. So 27% said all of them. 35% review 10% or less of the published articles. Some number of those journals said that they don't publish articles that are suitable for statistical review, so they might have been review journals. We have to actually look at those. And the median is 30%. So of this sample so far, a median of 30% of the articles have been statistically reviewed. So then we asked, among those who actually used 10% or more, we didn't pursue it further for those who didn't review very much, a series of questions. So here's the answers. At what stage is it solicited? And you see that about 70%, 80% is either after peer review or, that about half is at the same time as regular peer review, which is interesting. And the other half is after regular peer review or after provisional acceptance. How are they chosen? About 25 of 68, so that's about 40% are part of the editorial team, and about another 30% are in a pool of external experts. We asked how big that pool was, and one journal really messed us up with saying it had 200 people in its pool. But you will see that the mode is 1 down at the bottom. So the vast majority of journals had 1. The median actually turns out to be 4. So that could be 4 in the team or 4 external, but quite a number of journals use just 1 consultant. Are they paid? About half are not paid, and about half are paid either on a retainer basis or per review. Then we asked, are they given any sort of guidelines for their review? And we asked if they gave them sort of optional guidelines for them to follow, or a template that they were required to fill out. 35 of the 68, so about half, gave them nothing, neither. A few gave them suggested guidelines. Almost none gave them anything required. So a vast majority are sort of on their own. Does the statistical reviewer see a revised manuscript? And about 80% said usually or almost always. That's pretty good. How often, and this is a perception, how often does statistical review result in an important change in the manuscript? And these were, by the way, I should say, almost all the respondents were the editors-in-chief. So these are the perceptions of the editor-in-chief. 75% said, yes, important, with a fair number, obviously half above that, some below. How do you rate the incremental importance? So this was incremental over what they get out of the peer reviewers and the other editors. So the red and yellow, red is extremely important, yellow is very important. So the accuracy and completeness of the statistical methods description, so they vary, that's about 85%. They rely on the statistical reviewers for this. Strength of the study design, interesting, a little bit less, extremely and very important, although still about 80% of the sample. Appropriateness of the statistical procedures, that's on the bottom, that's almost universal that they relied on for that. The correctness of the calculations, still highly dependent on that, but not quite as much as the appropriateness. Presentations of the quantitative results, you can see about a quarter, very important, about a half, a quarter extremely important, and a half very important. And consistency of the results reported in the manuscript, tables, figures, and abstracts, you see actually a lot more here, or just in the moderately important category, although still dominated by very and extremely. I think this is because they think this can be done by a lot of, by other less qualified folks to look at the numbers the same. Interestingly, when we get to the adequacy of reporting study limitations, the importance of the statistical reviewer is a bit less. That's probably about 40% total there. But interpretations, the quantitative results, again, the vast majority extremely or very important. And then how do you rate the incremental value in evaluating the consistency of the conclusions with the strength of the evidence? Again, fair number in the extremely important, about half, 40% in the very important, and then about a third in the moderately important. Then we looked at what affects their decision to use statistical review. I was actually surprised by these results a lot. In the light blue, it's not at all important. And in the slightly darker blue, it's slightly important. So those two bars that I've now highlighted are basically, it's unimportant. And for the majority of respondents, the increase in reviewing time was not much of a factor. I was surprised by that. Although we actually asked them how long their reviews were delayed, and the vast majority were less than 2 weeks, with about half being 0 delay. The cost, I was actually then also surprised. The vast majority, about 85%, said this is not at all important. So either they weren't paying the reviewers, or the pay was negligible enough so they didn't care about it. I don't know which one. Or the reviewers were not demanding what they were worth. Then finally, difficulty in identifying statistical reviewers. Here we have about 40% of the sample saying it was important. The others seem to have what they needed. And then finally, uncertainty about added benefit. And there's an interesting discontinuity here. Here, about 90%, this is not the issue. They are not uncertain about the added benefit. That is, they do think it has significant benefit. But if they don't use them, it's for these other reasons. So this brings us to SMARTA. SMARTA is an acronym for Statisticians and Methodologists for Advising, Reviewing, and Technical Assistance. I'm waiting to hear from Howard. I'm not hearing anything yet. He's brewing over it. So what is SMARTA? So SMARTA is a large pool of high-quality methodologists that we're putting together to review biomedical journal articles, first for scientific purposes, and then perhaps, depending on what we find, as a pool available to the biomedical journal community. It's a collaboration with the American Statistical Association, the International Biometric Society, the US Biostat chairs, and several European statistical societies. Our goal is to use this to a smaller group, maybe on the order of 50, to do 2 projects. First, a large-scale, vertically integrated, and by that I mean actually reading every part of the manuscript and all of the statistics and all of the results, and not just looking at one method or one section. Reading the whole paper is a holistic assessment of the current use of statistics in the biomedical literature and its integration with design and claims. This is going to be a lot of work. And one of several questions we'll be asking, is it different in journals that use different kinds of statistical review? Won't be the only question. Second is that we'll then go from that phase, which will provide the baseline, to use this same team to evaluate different models of statistical review in the biomedical literature. And this is important because the idea of having a statistical consultant available with the time it takes for even if it's just one, for every biomedical journal, it probably outstrips the number of the capacity of the statisticians in the world. Who have the time to do this. So we'll be looking at the effectiveness of different models, the scalability of models, and the sustainability of models, both in terms of personnel and in terms of cost. And then, depending on what we find, and this will occur hopefully over the next few years, we might then proceed to making this group available. I will say that we started this with money, that we then lost the money, and then it looks like we might get back the money. So until I know that absolutely for sure, I can't promise all of this will happen, but it looks probable. I want to finish up with a quote from that 98 paper from Doug, and it's really wonderful. And this is the end of his article. He says, "I would summarize reviewing medical papers as difficult, time-consuming, sometimes interesting, sometimes boring, appreciated by journals, appreciated by authors, but perhaps not appreciated by employers, usually unpaid, occasionally frustrating, and educational. Many journals are desperate for expert statistical help. I recommend statisticians try it." Thank you, Doug, and thank you all for hanging in there.
We'll open it up to questions or to Howard's vote on the acronyms. You left them speechless, Steve.
Wow.
Well, so Annals has been doing this 2-stage process for maybe not in the current form for 30 years, and we've actually gotten to more complicated with a team of statisticians talking about the papers. So the most surprising thing that I found in this survey, and full disclosure, I was one of the subjects, was that it didn't extend the time of the review, and it may be because it looked like the majority of the journals were doing the review coincident with the external peer review, which we don't do. So I wonder what your perception.
We're going to have to do more analysis to figure that out. We haven't done all the crosstabs that we want to do and the size of these journals. We also asked things like how many articles do you publish in a year? That's going to have a lot to do with it. So I was surprised, and we'll also want to look at the crosstab of whether whether the ones that have the least delay are the ones that send it out at the same time as peer review. It's difficult to know how they could send it out at the same time as peer review because that means they're getting statistical review on a lot of papers that they're not going to publish. So that's a very inefficient use of their resource.
Yeah.
So we need to dig into this more to figure that out, but it was clear that, that at least the models that were being used, and I don't think there are very, very few journals that use the kind of processes that the Annals or the BMJ or the New England Journal or some of the top journals use, which is obviously a very involved process. So we'll have to look into that further and see what it is they're doing.
So let's take some questions. I think Kay was the first one up at the mic, so we'll start with you.
Hi, Steve.
Hi.
As you know, we're doing something that's a little different with ophthalmology and optometry journals where experts in systematic reviews are the editors for those papers. So one of the comments we've gotten back more than one of the comments we've gotten back from peer reviewers about this work, which is funded by the NIH, is don't you want to measure whether the quality of the papers will improve? And based on your work at this Congress, maybe 20 years ago, with Annals,
Yep.
I just wasn't sure how to measure quality improvement. Do you have, and what you showed us was the opinion of the editors, but what about
Right.
quality improvement of the papers?
Well, that's actually the second project that I said we were going to do. I don't know that we will assess overall quality, but we'll develop a metric having to do with a lot of aspects related to, first of all, there are things that you can measure in terms of use of statistics that are clearly right and wrong. So there's a lot there. When you start talking about whether the tone of the conclusions is consistent with the strength of evidence, then you're getting into far more subjective territory. So I think it's going to be a mix of subjective assessments, which I think we still have to make, and things that actually do pretty much have a clear right and wrong. So I don't know that we're going to be addressing all the dimensions of quality of the manuscripts. I think we're going to be assessing those dimensions of quality that are most closely and most plausibly related to statistical review. But it's, of course, you know, the heart and soul of the problem here.
Okay, let's go to the microphone in the back on this side.
Adrian Barnett, statistician. I love the holistic study. One variable you might want to collect is the sample size, because in my experience, the big data revolution or the big data bandwagon, depending on your perspective, big data is just bigger problems. And these big studies just have a lot more statistical concerns.
So I'm sorry, you're saying the sample size in what project, in which?
In the holistic study where you look through and look for problems.
Oh, yeah.
My suspicion is there'll be more problems in the big data studies.
Yeah, interesting. Well, we'll look at that and invite you to be part of it.
Okay, microphone in the back on this side.
Yes. Hi, Eric Turner with Oregon Health and Science University. I was wondering if you'd thought about maybe applying this to the registered reports model, which for those of who aren't familiar with it is a two-stage review, a pre-study review based on the methods, so there's not a biasing effect of knowing the results, whether the results are significant, and then a later review after the study is completed in the traditional manner. So I'm wondering how that might particularly be relevant to a statistical review, whereas oftentimes a statistician, as I understand it, is not even approached until the horse is out of the barn, the study's done, and then the basically the statistician is doing damage control, trying to make a silk purse out of a sow's ear.
Right. So actually, it's interesting you mentioned that, since Tom Hardwick, who's working on this project, has been very involved in the registered reports effort as well. We honestly hadn't thought about that because we hadn't thought about using this as a part of the process of improving the science itself earlier on. It's an interesting idea, and we're looking for creative ideas. So that's something we may take on going forward. Well, one thing I do want to say in general, if there are folks here who would want to be involved in this, please contact me, because this is sort of a prime ground for finding statisticians, creative statisticians who'd be a great asset.
Okay, we have 4 more minutes for questions. Doug?
Yeah, thank you, Doug Altman. Thanks for your comments, Steve. Firstly, a comment. When journals send only those papers they think need statistical review, they often make the mistake of thinking the more statistics in a paper, the more likely it is to need review, but actually often it's the papers with very little statistics.
Yeah, absolutely, right.
Yeah, okay. The other point I wanted to make was that I think most statisticians would agree that the study design and the data quality are fundamentally important, and you didn't really talk much about that. It was more about analysis and interpretation, but quite often we would strongly recommend rejecting a paper because the design was either inappropriate or poorly executed.
Well, the assessment, so you notice that we did ask for the editor's evaluation of the assessment of the design. So that's certainly going to be something that we're going to want to look for in the project going forward. So I totally agree with you. That said, it will be, we'll only be looking, I think, at published papers. So it will be already papers who've gone through that filter or gone down the hierarchy of journals.
Okay.
Thank you.
Okay. This mic?
Hello, I'm Chris Graff. I work at Wiley, the publisher, and I volunteer at COPE. And my question is, do you think that it might be possible to recruit machines and to teach them how to help the humans that are involved in statistical review?
So I'm getting old. There already are some software tools to catch some of the things that we've talked about here. I personally doubt whether what I think is the heart and soul of statistical good review, which is uniting the numbers and sense and the science, can be automated. But I do think it's a fair question to ask what aspects of this process can be automated, for which then the statistician or methodologist just provides added value. And I do think we're going there. I don't know how much, and I don't know how powerful the tools can get. But there's a lot of this, I think, that creative, energetic young people could do to take the burden and time. This is what I mean by creating scalable and sustainable models off of the basic housekeeping and using the methodologists for really the higher level stuff, which I doubt, but they never thought a computer could win at Go or chess. So, but that's still a constrained universe there. So I don't know where it's going, and I think we need to be talking to the folks who are doing that sort of work and looking carefully at the sort of tools that are coming out, because there's no question that they're going to play somewhat of a role here.
So unfortunately, we're out of time for questions, and I am under orders from Annette Flanagan, so I'm going to stop on time. Just a couple of housekeeping items. So immediately after this session is the 8th annual Equator session. Tomorrow, the meeting starts again at 8 a.m. Breakfast will be served at 7. And then following the closing session tomorrow, there will be the peer review week session on transparency and peer review, and that starts at 5:30. So thank you, everyone, and stay around for the Equator lecture.
Okay. Hi. It's my pleasure to host this 8th annual Equator lecture, or almost annual. I just briefly want to say a few words about Equator, although I hope most of you know about it, and many of you will have visited our stand next door. But we set up the Equator Initiative in 2006 to help to improve the reliability and value of medical research, or the literature, by promoting good research reporting, trying to improve the accuracy, clarity, completeness, and transparency, and you know, here we are sort of 12 years, 13 years later, and it's quite clear there's a lot more work to do. We set it up because we saw widespread deficiencies in research reporting, and that although several reporting guidelines existed, they were perhaps difficult to find and rarely used. Basically, I'm not going to go through all the details because I know it's been a long day and we want to get to hear Patrick. But the core program of Equator is to raise awareness of these problems and the existence of helpful resources, and indeed to provide those resources on our website in particular, to ensure that people have easy access to reliable, up-to-date resources to help them write their papers. And I should just mention that Equator, although you may think of it only about reporting, we are also very interested in guidance for research conduct, but we haven't done a great deal on that as yet. We also develop education and training programs. That's our website, the front page, and it links very quickly to, in particular, the block in the middle, to the most common reporting guidelines. And you shouldn't be put off by the fact that there are nearly 400 reporting guidelines. Most of these are very specialized, and really the core guidelines probably are somewhere between 15 and 20. We've had, since 2006, we've had 7 annual lectures, so you'll see what I mean when I say it's not quite annual. Those are the people who've, I'm not going to name them, but 3 of them are here. Those are the previous 7. The 8th person to deliver this lecture, sitting on my right, is Patrick Bossuet. He is Professor of Clinical Epidemiology at the University of Amsterdam. He's also head of the Division of Public Health and Clinical Methods in the Academic Medical Center in Amsterdam. He studies, in particular, the effectiveness of clinical interventions and helps to translate study results to recommendations for practice. He's, in particular, known for his work on diagnostic research, I think, and he leads the biomarker and test evaluation research program in Amsterdam, which aims to appraise and develop methods for evaluating medical tests and biomarkers. This is a large part of the medical literature which has had very little coverage thus far at this meeting. Anyway, Patrick spearheaded the STARD initiative, which is a reporting guideline aimed at obviously improving the reporting of diagnostic accuracy studies, and we're going to hear quite a bit about that in a minute. Lastly, Patrick chairs the Scientific Advisory Committee of the Dutch Health Insurance Board, which oversees the National Healthcare Benefits Package. So you'll see it's quite a wide variety of really important activities. It's my great pleasure to hand over now to Patrick to deliver the Equator lecture.
Thank you. Well, thank you, Doug, for that kind introduction and for the invitation to present the annual Equator lecture and to follow these highly esteemed and respected colleagues. My disclosures, I'm a committed consequentialist in test evaluation. It's all about the consequences. But I think I have no actual potential conflict of interest in relation to this presentation or the test that I will mention during it. So, as Doug said, I work in Amsterdam, unfortunately not in the city center, in the beautiful canals, but south to the center, in this university medical center. And I arrived there 26 years ago, and what I'm doing inside is work with all kinds of clinical specialists to run trials, randomized clinical trials and otherwise, to find out about the effectiveness of interventions. So most of what I do is not about diagnostics, it's about other trials. But the problem was that when we were thinking about studies to evaluate medical tests, we found out many, many years ago that we lacked proper methods, that it was very difficult to come up with the right study design to show that medical tests actually improved patient outcomes and that they were efficient. It's not just imaging, it's lab medicine, pathology, all kinds of markers. So if we ask ourselves how to evaluate medical tests, we basically have three sets of questions. And the first question is this test trustworthy? Is a 12 really a 12? Is a sign read by a radiologist also read by his colleague? And these are questions about the analytical or technical performance of a medical test. But more important is whether the 12 means anything. Is a 12 meaningful? And does the sign carry any clinical information for the clinician? And these are questions about the clinical performance of medical tests. And the bottom line and probably most interesting question, is the test helpful? These are questions about the clinical effectiveness of medical testing. What I'll be talking about today is clinical performance of diagnostic tests, so about diagnostic accuracy. I will briefly sketch why and how we developed STARD, and then discuss the probably interesting question about whether STARD was effective. We will discuss the update of STARD, and I will discuss the side effects of STARD, so what a reporting guideline can do beyond being thrown at authors by editors or by reviewers. But first a bit about diagnostic accuracy. And to use an example, I will use pulmonary embolism, which is a potentially fatal condition for which there is effective treatment, but it still lists as number one in the lists of missed diagnoses. So it can be missed with fatal conditions. And I will focus on one family of tests, and they are called D-dimer, and it's a fibrin degradation product, so protein remains of clotting, and when it's present, it could signal a pulmonary embolism or more general thrombosis. Now, in diagnostic accuracy, we ask ourselves the question, how good is this test in correctly classifying patients as having the target disease? That's the question in diagnostic accuracy. But most cases, we're not interested in disease in general, but a specific target condition. And to answer that question, we designed a diagnostic accuracy study. That means that we will look at the medical test, D-dimer, and try to compare it against the gold standard, which is the error-free method for finding out whether patients have the target condition. Now, in most cases, including pulmonary embolism, there's no real gold standards. We have to do with a clinical reference standard, and that's the best available method. It may not be error-free for finding out whether patients have the target condition. And the structure for pulmonary embolism, in most cases, the clinical reference standard is imaging, and most hospitals will rely on CT imaging. So a diagnostic accuracy study is quite simple. It means that we take a series of patients in whom we suspect the target condition. They all undergo the index test, they all undergo the reference standard, and then we simply compare the two. And if the test is positive or negative, and the reference standard present or absent, it's a simple 2-by-2 table. Here's an example of a diagnostic accuracy study of D-dimer in its ability to exclude pulmonary embolism, published in 2016. And the results of this study, like most diagnostic accuracy studies, can be summarized in a 2-by-2 table with the true positives, the false positives, the false negatives, and the true negatives. And from these 2-by-2 tables, we can calculate the measures of diagnostic performance, the measures of diagnostic accuracy. And the most familiar ones are the sensitivity and specificity, so the percentage of disease correctly classified as such, and the percentage of non-diseased patients without pulmonary embolism correctly classified as such. But we can also calculate predictive values, and in this study, the authors were especially interested in a negative predictive value, so the proportion of negatives who didn't have the target condition, and that was 99.8. But we can also calculate likelihood ratios or diagnostic odds ratios and 24 other statistics, but that's not the topic of my talk. The topic of my talk is the following. When I first took courses in study design, I learned that sensitivity and specificity are fixed test properties. And I was even invited to write a book about the sensitivity and the specificity of all tests in lab medicine. Now that's complete nonsense. Actually, they're not fixed. Actually, they're in fact extremely variable. And to highlight that, I will give you a few examples about D-dimer, and these are the D-dimer results in patients who didn't have pulmonary embolism. And what you see are the mean values across age groups. And the mean values actually rise with age. And that means that in patients who don't have pulmonary embolism, the number of false positives will increase in elderly people. So you will have a lower specificity in elderly people. It's not constant, it varies with age. It not only varies with age, but it varies with more elements. This is a plot in ROC space, because D-dimer can be a quantitative test, and then you have multiple combinations of sensitivity and specificity. The dots in this plot correspond to the recommended threshold by the manufacturer, so high sensitivity and mediocre specificity. And this is a study in which they compared two D-dimers from the family. Now, the authors performed the study in outpatients, but they used the very same tests in a series of inpatients with suspected pulmonary embolism. And the results are shown actually in this slide. And what you see is a dramatic decrease in specificity, so far more false positives in inpatients than in outpatients, with the same tests, the same investigators, same protocol. And it's not difficult to see why, because the false positives are generated by the other conditions for which the patients are in hospital. So it matters if you evaluate the tests in inpatients and outpatients. But there's even more. So in our hospital and many others, they rely on a clinical decision rule. They look at the signs and symptoms and classify patients as having a low probability of pulmonary embolism, medium, or a high probability. But let's just count signs and symptoms and see how D-dimer does in the respective groups. So here again you see a plot in ROC space, the combinations of sensitivity and specificity for patients with 0 of these items positive, so no signs and symptoms that suggest pulmonary embolism. Yes, that happens. For example, if D-dimer is tested routinely in the emergency department, 1 item positive and 2 items positives. And again, you see a dramatic difference in specificity. So the specificity is much lower and significantly lower in those actually that have more signs and symptoms that suggest pulmonary embolism. And the specificity is about 50% in those who don't have a suspicion for pulmonary embolism. So we see that these elements vary, and that means that if you do a systematic review of tests of D-dimer in suspected pulmonary embolism, you get pictures like this. So there's random variability, but a lot of the variability is true heterogeneity because the test was evaluated in different patients, different settings, and maybe also because there are different D-dimers. Now, if we read a study about D-dimer, what do we know about the patients that were in the study? Well, the truth is, not in most, but in many studies, we don't know much about the patients that were included. So these were results from an evaluation in 2000, and where we looked at the inclusion and inclusion criteria in the setting, and it was mentioned in about 1 in 4 papers. So 3 out of 4 articles never mentioned the eligibility criteria, and they actually 1 in 2 didn't even tell us whether they were males or females, or whether they were young patients or elderly patients. So these authors believe that sensitivity and specificity are fixed, so they don't need to tell us where they evaluated them. But there's more actually in diagnostic accuracy studies. We have variability, but we also can do studies with deficiencies. For example, this is the typical study. All patients with suspected pulmonary embolism undergo D-dimer and then CT pulmonary angiography. But in some studies, the authors include, for simplicity, patients with massive pulmonary embolism and healthy controls. For example, first-year medical students who are invited to contribute to science. And then they estimate the specificity in the first-year medical students and the sensitivity in patients with massive pulmonary embolism. Now, there could have a reason for that, but the sensitivity and the specificity will not reflect actually the behavior of the test in clinical practice. Sensitivity will be too high and specificity probably also too high. But there are other deficiencies as well. For example, in many studies, we will not have this picture, so a full 2x2 table, but some patients will not undergo the reference standards. And that could be for random reasons, and if it's just random, then we have, for example, half the patients have true positives, and we will have less precise results, but no real bias, no systematic bias. But in most cases, the patients that undergo the reference standard will be distributed differently across the 2x2 table. There will be more positives who undergo the reference standard than negatives, and more patients with the target condition than patients without the target condition. Now, if we estimate sensitivity and specificity based on these results, we miss the false negatives, and we will overestimate sensitivity. And we also have bias in specificity. So if not all patients undergo the reference standard, we will introduce bias. Now, a potential solution, which was also used by the authors, is to use follow-up. See if anything happens, for example, in negative patients. And if nothing happens, a negative is called a true negative. But if the patient is admitted to hospital, he is called, and pulmonary embolism is found, he's called a false negative. So now we have a reference standard in all patients. Some have imaging, and the others have follow-up. And it seems that we've reconstructed a full 2x2 table. But it's not exactly the case, actually, because that only applies if CT and follow-up are interchangeable. And it's very likely that not all patients with a lesion, with an embolus on imaging, will have an event if left untreated. Actually, some will resolve by themselves. So that means the two results are not interchangeable, and some patients who would have been classified as pulmonary embolism based on imaging are classified as no pulmonary embolism based on follow-up. So the 2x2 table is reconstructed in the following way that we will have, if we see it in a minute. Ta-da! Yes. No, that's okay. In the following way, so we have the false negatives are now classified as true negatives, and we will overestimate sensitivity and overestimate specificity if we use two different reference standards. And you can say, Patrick, that's all very well, but these are all anecdotes. Does it really matter? Yes, it does, because we compared studies with complete verification, one reference standard, and studies with two reference standards, and studies using healthy controls, and studies using a single series of patients for the same disease, the same tests. And what we found out is that there was empirical evidence for a systematic bias in these kinds of studies. So in our comparisons in studies with deficiencies, in studies without deficiencies of the same test, we found evidence of a systematic bias. And the two features that stood out were the use of healthy controls and the use of different reference tests. This was a very difficult study to do because in most cases the things were poorly reported. So we had to do an independent scoring of the articles in different rooms because we had to limit the amount of strong language that was typically used by one scorer who could not find the necessary information, whereas the others was also cursing because the information was finally found to be found in the discussion section. Now, Jeroen Leimer, who did this study, came up with the idea for a reporting guideline. Actually, it was not part of my initial plan, because Jeroen Leimer went to the Cochrane Colloquium in Rome, if I'm 99, if I was correct. And there he had a discussion with David Moher, and I think also with Drummond, but I'm not sure about that. And they say, we should develop a reporting guideline, because the logic is very simple. If the information is crucial and often not reported in the articles, there should be a consort-like reporting guideline for diagnostic accuracy studies. So let's try and develop one. So we assembled a steering committee that included Jeroen, but also Drummond and David. And David Bruns, the editor from Clinical Chemistry at the time, Konstantin Gatsonis, a statistician, Les Erwig and Paul Glasio from Australia, and other colleagues listed on this slide from Amsterdam. And we started preparations for a meeting, a consensus meeting, and the preparations included developing a long list of all the items that had been suggested as essential in reporting these kind of studies. And these were in total about 130, 140 items. And then we assembled a group of researchers, editors, people from professional organizations, funders, methodologists, whom we invited to the consensus meeting. And to our relief, actually most people agreed to come. Only the ones I indicated with a star actually were not able to make it. And that may have to do with the dates of the consensus meeting, September, and also with the location, because what better city to organize a consensus meeting than Amsterdam? Actually, very few people could resist the temptation actually to visit Amsterdam for this meeting. So I think they were convinced of the importance of the consensus meeting, but the location helped. Then where in Amsterdam? Well, most people would be arriving at Schiphol Airport, so we selected this beautiful hotel, which was very conveniently located near Schiphol. But then we had made all the bookings, and they said, well, this is not possible. Actually, you invite people to Amsterdam, and then you have a consensus meeting in this bland hotel. No, that's not possible. So at the very last minute, the rooms were already booked. Actually, we also booked this magnificent building in the city center of Amsterdam. It's the house of the Royal Academy of Science. And both mornings, it was a weekend consensus meeting, there were small vans actually moving all the people to this building in the city center. And it really is a magnificent building with all libraries and carpets and so on. And it had the desired effect, because we invited people to the consensus meeting and they were so impressed by the building that they kept silent the whole morning. And we made great progress. But in the afternoon, actually, people got used to the building and they said, wait a minute, I didn't come to Amsterdam actually just to sign at the dotted line. So we had very heated discussions about the items that should be in the consensus guideline. And actually, the only solution actually to end these discussions was to have a dinner in this beautiful building nearby with French wines and Belgian beer, and the dinner lasted all evening. And during that night, a couple of us stayed up and developed a consensus. And on the Sunday morning, everybody was very happy to see the consensus after that wonderful dinner, and agreed with the consensus and left. And the consensus was piloted for more than a year, and eventually, you can see it on this slide, it was a single-page checklist of essential items that should be reported in diagnostic accuracy studies. And it included, for example, had an invitation to report about the participants. So tell us the eligibility criteria, but not just the eligibility criteria, but also tell us where you found eligible patients. How did you identify them? And where then identified? What was the setting? And please give us the dates. And were they a consecutive series or a random convenience sample? So these items were part of STARD. And after piloting and testing, the STARD checklist was published in 24 journals, thanks to the generous help of the members of the steering committee and the members of the STARD group. So 24 journals published it in January 2003. And actually later we invited journals to endorse STARD, and that led to a long list of journals who wanted to endorse STARD. It also was translated in many, many other languages. A few of you can see on this slide. So we were very happy with that publication in 24 journals, but the critical question is, well, did it have any effect actually after the publication? And there have been before-after studies. And this is the general conclusion. Yes, there are some improvements after 10 years of STARD. In actual fact, there's even a systematic review of all the before-after studies. And here you can see the results. It's a bit of a busy slide, but on average, the mean change is that there's one more item reported after the publication of STARD. Fortunately, it's a significant gain. It's interesting to see what the distribution is of articles that report multiple items. And that's shown on this slide. So you see the percentage of articles in the evaluations, in a couple of the evaluations that report the number indicated on the x-axis. And the median number has changed over the year. But if you see the three curves, you see that there are more articles publishing more items, but that the gain is mostly at the bottom. So there are a couple of articles that seem to adhere to STARD quite substantially, but there are also small pockets of resistance actually on the top of this slide. So items that just by chance maybe mention a few, articles that mention a few of the items, but still fail to include essential information, such as eligibility criteria. So yes, there is change, but it's going very, very, very slowly. This slide, for example, mentions the items that I mentioned earlier. So please tell us the inclusion and exclusion criteria. So in 2000, it was 1 in 4 of the articles. But fortunately, over the years, it's now actually has grown to about 65 of the percent of the articles. So more and more people think that it's good to report what the eligibility criteria were for the study. And the improvement is also there, but less pronounced in the other elements of the STARD checklist. So I can write as a tutorial, I think, every year, there's still room for improvement in the reporting of diagnostic accuracy studies. And one of the reasons for the room of improvement is the rather loose language that is used in the instructions to authors. This is a somewhat older list, but it lists the wording that is used in the instructions to authors by the respective journals. So some journals say that you must use or should reflect the reporting guidelines, but other journals say, please refer to the reporting guidelines, or please use the reporting guidelines. So rather loose language, and that hasn't changed over the years. So it's still it's still optional for many journals. After a number of years, we decided to update STARD, and I think the rationale for STARD, the update, also changed. What we wanted to do, despite the original Python, is improve the ease of use, because we found out that authors still found it difficult to use the guideline. They were also confused because some of the language used in STARD differed from the language used in consorts. So we use different wording than Doug and David and the colleagues in the consort team, and maybe that's confusing. So why not harmonize the expressions? We wanted to include new evidence about sources of bias and limitations in applicability, variability. We also wanted to include other issues that became more important in reporting, like issues related to integrity. And you heard about SPIN yesterday. This is a study of SPIN in diagnostic accuracy studies. And what impressed me actually were these numbers. In diagnostic accuracy studies, 90% of the studies that we analyzed, the random sample, did not have a sample size calculation. They did not have a test hypothesis. Actually, the majority did not report the imprecision out the estimates. And about 1 in 2 did not specify what the test was going to be used for. Now, if you don't know actually what you're studying, you can make any conclusion about your article. So it's no surprise that there's so much spin, because these elements are not specified in many articles. And that's why the revision of SPIN also includes a number of other elements, trying to limit, the revision of STARD tries to limit the amount of SPIN by asking authors some of these additional elements. I'm also skipping this. Now the STARD group was accused of being a bit too inclusive, too small in 2000. So what we did is extended the STARD group. The STARD group now exists of 85 people and includes multiple stakeholders. It includes funders, medical journalists, clinicians, and an increasing number of methodologists. Unfortunately, we did not include patients and some other stakeholders that are sometimes mentioned as necessary participants in the reporting guideline development process. And with these 85 people, we had a Delphi procedure, and again a consensus meeting in Amsterdam with the a smaller team that was making the necessary judgments, final judgments about the inclusion and the revision of STARD. And you can see some of the usual suspects on this slide. So the update appeared in 215, not in 24 journals, but in Clinical Chemistry and Radiology and the BMJ, actually 3 journals that strongly supported STARD from the beginning, and that reach out to different audiences. It still is a one-page checklist, so we removed items, simplified items, and added a few others. So STARD had a limited effect on the number of items reported, but did it have other effects? And while preparing this presentation, I started to think about these other effects, and I think that reporting guidelines should not be judged by the number of items that are mentioned in the articles. One of the benefits is also to improve the terminology. So the terms that are used for describing diagnostic accuracy study. Here is a study that I mentioned in the beginning, the study of D-dimer in suspected pulmonary embolism in 2016. The study does not mention STARD. Actually, there's no reference to the reporting guideline, but nevertheless, it uses the word diagnostic accuracy. And it's not alone. The term diagnostic accuracy is now increasingly being used for this type of study. There was no such term in 2000, and diagnostic accuracy had another meaning, usually the number of patients correctly classified in total. By the way, this such increased number of hits in PubMed should always be corrected for inflation. And there you can see that STARD actually hardly made a dent in itself. But if you look closely at the more recent publications, then you see that it's used for this type of study. There are other elements in the terminology that have been influenced by STARD and in the reporting. So this study does not mention this reporting guideline, but it includes a flow chart. One of the elements that was recommended by the STARD reporting guideline. When we developed STARD, only 2% of studies included such a flow chart, and the number has now risen to about 40%. And because diagnostic accuracies can sometimes be very difficult in terms of the flow of patients, we believe that such flow diagrams can be very helpful. There are other terms as well, like the reference standards, which is now increasingly being used as the replacement for the gold standards. And the target condition. Target condition is also a term that's increasingly being used not just in the, in the reporting guideline, but also in many articles, the condition that we try to identify with the diagnosis. But there's more terminology needed. You can always recognize a field in the debates about the terminology. For example, in the types of studies. So I presented the basic study as one that included all suspected patients. And then you have on the left the cases and on the right the non-cases, the patients with and without the target condition. And they probably differ in severity. So a single set of inclusion criteria and a single definition of disease. But we also have these studies with extreme phenotypes. And we have no good label for calling these studies anyway. So they're sometimes called case control studies. But that's an insult to the epidemiologists because they're not really case control studies. Even if they include healthy controls, case control studies would be a subsample of the cases and the controls and not these extreme phenotypes. So we need more terminology. Now, STARD is also used in teaching, and increasingly we get emails from people that tell us that the explanatory document is their key resource in teaching diagnostic accuracy studies. So this long document is not just used by authors who want to evaluate the completeness of their reporting, but it's also used in teaching diagnostic accuracy studies. And the elements of STARD also appear in quality appraisal instruments, like this risk of bias tool for diagnostic accuracy studies, who builds on the things collected in STARD. Now, STARD has also been the starting point, no pun intended, for other initiatives. We've developed a STARD for abstracts, which appeared in BMJ recently. And we also developed a checklist that can be used for including a diagnostic accuracy study in clinical trial registries. Because we believe that diagnostic accuracy studies, most diagnostic accuracy studies, are also trials and should be registered before they started for the very same reasons that we expect randomized clinical trials of pharmaceuticals and other interventions to be included in trial registries. And while many of the registries were not developed for diagnostic accuracy studies, our article in Clinical Chemistry shows that it's not too difficult to use the existing fields to include the necessary information building on STARD. And we will also develop STARD for protocols in the very near future. So what about the future? Well, I think that we were extremely naive in 1999. We believed that we could change the world with a manuscript. That the only thing that we needed was a paper, a checklist, and publication in 24 journals, and the rest would follow. What we didn't think through enough in 2000 was our plan actually to change the reporting. So how and where will authors find these documents? When will they learn about it? At what stage in the review process is it necessary or most efficient to use these reporting guidelines? I believe now that the reporting guideline is never the end product, but that the list of essential items that was developed in 2000 and in 2015 is only the beginning of a larger campaign that probably will last my lifetime, if not longer, to improve the reporting of diagnostic accuracy studies. Because it's still necessary. People rely on the information in articles to make decisions, and they should find all the necessary information without spin in the reporting, of such diagnostic accuracy studies. Thank you very much for staying so long for this presentation. I'm happy to answer questions. Thank you.
Okay, thank you very much, Patrick. Yeah, we'll go straight to some questions, and over there, please. Hang on.
Equivocal test results?
STARD deal with what?
Equivocal test results, intermediate, indeterminate, and interpretable results?
There's specific items about the handling of intermediate or unclear results and about the handling of missing data.
Thank you.
Can I ask you whether you've experienced resistance, sort of hostility to the idea? Because we sometimes encounter the idea that you're treading on in other people's territory, if you like, and telling them how to do their research, which clearly you're not. Well, yeah. Not explicitly anyway.
Oh, yes. So we've encountered hostility from a number of groups. From journals, that you're actually killing the creativity of our writers, of our authors. We received very hostile papers from journals. The second was from authors that said, actually, you're telling us how to do studies, which is not the case. We invite authors to be clear and complete in their reporting. So just tell us what you do, and then others can judge whether it meets whether the study design meets the research question. We also encountered hostility in terms of terminology. For example, the people in metrology said, how can you use reference standards for an imaging procedure? A reference standard is an infallible reference standard, and a CT can never be a reference standard. Then we explained, no, it's a clinical reference standard. It's what's used in clinical practice. So yes, over the years there was a lot of resistance, but that gradually declined. It's much better now. Yeah.
Okay, great. Yeah, please.
I noticed in one of your slides that you plotted the frequency with which particular items were reported over time, and I saw for one of the items there was a peak in 2004 and then it had actually dropped back. So I guess wondering if you could comment on whether there's any evidence for guideline fatigue, I guess. Particularly as, you know, people are being required to comply with increasing numbers of guidelines.
I don't think there's real guideline fatigue. Although I must say, if I submit a paper on a diagnostic accuracy study and the reviewer tells me or tells our team, you did not use STARD because item 12 and 13, there's a certain sense of fatigue with me that I failed to recognize the necessary items. It happened to me. No, actually, as we heard earlier today in the presentation from Mark Dewey, that actually the introduction of the reporting the required use of reporting guidelines, for example, in radiology went rather smoothly. And there was not a massive revolt of authors that all of a sudden took their papers to a different journal. There could be a sense of fatigue in the, but that's a larger discussion and a question for Doug, with 400 guidelines. So how to find them, when to use them, what if there are conflicting guidelines? So yes, in the end, the Equator faces a challenge with the growth of reporting guidelines and there are initiatives to help people to select the right guideline, of course. But I don't think there's a general sense of fatigue.
Perhaps I could just comment. There's a surprisingly little duplication of territory amongst those guidelines. Although they do get more and more niche in the areas they relate to. And as I always say, probably no more than 20 would cover pretty much the whole spectrum. The one area that's missing is laboratory research, not animal research, but wet lab research, which I haven't seen guidelines for, and since I can't understand those papers, I'm not willing to get involved.
Yeah, there are some guidelines for some of those things, I think, and for example, there's, I think the Miami was the first, so minimal sort of reporting information for microarray experiments.
Yeah.
Then there's proteomics. The thing that I've been a bit involved with is the biospecimen reporting, the BRISC tools, and I guess BRISC is an example which has been adopted by a number of journals in terms of people who use biospecimens in research and meant to adhere to Tier 1 BRISC reporting guidelines, but you don't tend to see a lot of it actually in papers or a discussion about how people have done it. I'm about to go to a biobanking conference in Sweden, so I'll be interested to look at to see whether there's been any update on the use of those guidelines in biobanking.
I think most of those guidelines, like Miami, are more focused on the data rather than the study design and the participants and so on. So they're not truly analogous. I'd like to ask the editors. Do you want to ask a question?
Quick question, maybe. David Schreiger, UCLA. I worry a little bit about a different unintended consequence of these things, which is, take pulmonary embolism. It's my belief that we're doing far too many D-dimers, leading to far too many CAT scans to detect pulmonary embolisms that are probably of no clinical consequence. And what's happened to some extent is that the better studies that have been compliant with STARD and therefore are thought to be good studies fuel this kind of testing madness. And kind of carry an extra weight because they have the imprimatur of STARD and all of this. And what's really missing is careful thought. And that there's this danger that while I agree that complete reporting is important, that all of a sudden completing the reporting guideline and being compliant with it gives it a seal of approval that's beyond what it's worth, and that it acts as a substitute for real careful thought about whether the study results mean what the people would like to think they mean.
Yeah, I agree. And that's why I showed the initial 3 questions, that the bottom line question is whether testing is helpful. And even despite the accuracy of the dimer, in many situations, it probably leads to over-testing. And there are some concerns about an overuse of CT scanning because of positive D-dimers, even in my institution. So yes, accuracy is only about a small bit in the total, actually, decision-making about medical testing. I don't think that the studies themselves stimulate overuse. I think it's more difficult, and that the STARD seal of approval would encourage the use of the test. That's a very strong accusation.
It's not so much an accusation, it's a concern that as we become, there's an advantage to standardizing things, there's an advantage to making lists of things that are important, but there's a danger in that, which is when that begins to substitute for careful thought, there's an unintended consequence. And I just raised that issue. I agree. Not just with STARD, but with all the guidelines.
Yeah, Hal.
Perhaps I missed this, but are studies of diagnostic test performance getting better sort of in parallel with relatively non-use of the guidelines? Is it getting somehow baked into our DNA to do it right despite non-use of STARD and other guidelines.
Yep. Well, thank you for saying that, because I was so concerned about time that I missed that point. So what I see is that gradually things are getting better. So from our systematic evaluations of the literature, we see improvements. And we see improvements by, that's why I showed the study, with people that don't refer to STARD. But in general, I think there's a better understanding with reviewers, with authors, and with scientists about how these studies should be done and how they should be analyzed and interpreted. And my belief is that STARD was not the causal factor that changed all of that, but was one part of, and probably, I hope, helped to achieve that change. I don't think it's a spontaneous change of the DNA of researcher. I think it's the efforts of a lot of people that are teaching study design to junior researchers in lab medicine, in imaging, and in clinical medicine in general.
Change is complicated.
Yep.
I'd just like to note that you published both versions of STARD in multiple journals. I think the first example of that was the Consort 2001, which was published in 3 of the leading general medical journals simultaneously. I think you probably hold the record with your 24. I think I haven't got anywhere near that in my papers, but I just wondered if any of the editors wanted to comment on the pros and cons of publishing the same paper in multiple journals simultaneously, which I guess is designed to reach multiple audiences in this sort of super connected world now, PubMed and the internet and so on. And I've heard conflicting views, but just to go on, I was trying to provoke somebody.
Trish Groves and Elizabeth Loader will rescue me too. Fiona Godley, BMJ. Yeah, it does occur to us that this is a bit ridiculous still to be doing it, but the awful naked truth is that these checklists are highly cited. So actually, you're in a seller's market when it comes to them. And I guess, I mean, I don't know if Elizabeth and Trish or anyone wants to contradict me. They've all gone, just in time. Or maybe Christine Lane is here. No, I'm alone. There we go. That's my honest truth. Drummond, your hero. I hope you're going to support me in this.
I support you in everything, Ed. However, coming to this, I was there and you asked this question, and the idea, of course, was simply to have Anthony Proto as a step, as a radiology journal editor, to help with the buy-in of all the radiologists doing their tests, to have David Bruns in clinical pathology for the same reason. A big effort was made like that. I feel it was really important.
Sorry, excuse me, can I just add something else? One of the crucial things about these guidelines is that they be freely available, open access. And I do think, I'm going to just say for the BMJ, all of our research methods and reporting articles are open access. So I think if you're going to go for one journal, go for an open access journal.
Okay, thank you.
That's true, yeah. And also the STARD update was explicitly released under a Creative Commons license that allowed for reuse and distribution, which was not the case in 2000. So the copyright, for example, for the 2000, despite the fact that it was published by 24 journals, was a bit vague. So I think it's a big bonus that we make it explicitly available for not just the articles in open access, but the checklist are freely available.
Okay, final question.
It's more of a comment. I am a radiologist, Debbie Levine. I can kind of speak for Tony Proto because I was there at the time. And it was really important to reach the different subspecialties that don't always cross-communicate. We didn't have internet access the same way now to articles from other journals in 2003 that we do now. And I think that even though we'd like to not have duplicate publications. Sometimes there's articles that are so incredibly important that you want different subspecialties to have the buy-in from their groups. And so I would say that it is okay still to do it in more than one journal.
Okay, thank you.
I think the leadership of radiology in the imaging field and of clinical chemistry in the lab medicine field were incredibly important at the time, and that they agreed that this single checklist was also to be used in other areas. That was terribly important.
Okay, brilliant. Thank you very much, Patrick.